Hello everyone, welcome back to Smartens YouTube channel. My name is 𝗟𝗲𝗃𝗲 and today we are going to discuss Codechef Starter 207 𝗙𝗶𝗃𝗃 problems. So let's get started.
Okay guys, we'll start with the first problem, that is tourist. Chef is now a tourist in a foreign land. The land can be modeled as an infinite 2D grid. Chef is currently at some location A, B. There are total actually n attractions and the ith attraction is a coordinate xi, yi. Chef want to visit only one attraction, but he does not care which one. We need to find the minimum distance Chef need to travel to reach some attraction here. Okay, he want to only visit one attraction, which is the minimum one. We need to find out which is at a minimum distance. Here, distance is measured by the Manhattan matrix, where Chef can travel along the parallel to one of the axes here. For example, the distance between 0, 0 and 1, is going to be 2. Okay. So I hope the question is clear. Chef is at some currently index A, B. Total there are going to be n attractions, but he wants to travel to only one attraction, which is at the nearest location. We need to find what is that nearest location where we have that, like what is the minimum distance where we are having that attraction. We need to find the minimum distance here. How we are measuring the distance here? It is by the Manhattan matrix. So if I take, like, if I have to tell you what is a Manhattan matrix here, how do we find the distance? Let's say if the Chef is at 0, 0 and attraction is at some 1, 1. Okay, so if I take this as a x1, y1, and if I take the attraction as a x2, y2, we call or we find the distance using Manhattan matrix is something like absolute of x2 minus x1, absolute of x2 minus x1 plus absolute of y2 minus y1. So if you apply to the above one, you will be getting as a 2 here. So the distance you will be getting here is going to be 1 minus 0 plus 1 minus 0 here as well, which is going to be 2. So this is how we find the distance between any two coordinates using a Manhattan matrix. Let's look at the, like, what is given in the sample input. Number of test cases. You are given the n. Single first line contains single line t, denoting the number of test cases. Each test case contains of multiple lines of input. First line contains n, a and b. N is nothing but how many attractions are there. A, B is nothing but the initial location of the tourist. The next real line contains two integers each, the ith being the xi, yi. We need to find if there are multiple attractions from the current location of the Chef. Which one is the nearest one? We need to find that. So let's quickly do that. So first I will read n, a, b. Then for all the attractions, I need to read whatever the attractions are there, locations are there. I need to read each and every one of them. You can take a other variable names as well, but here I am just taking C and D. Min distance also I need to take care about. So initially I can say min distance equal to int max, and here itself I can check min distance equal to minimum of whatever the min distance I'm having so far, comma. I will try to apply this formula here for finding the distance between the current attraction and the location of the Chef. So that is going to be absolute of C minus A plus absolute of D minus B here. At the end I will be printing min distance. We need to print. That's it. That should be enough here. Let's try to run our code once. We are getting the same output for the sample cases. Yeah, that's all for the first problem. Coming to the second problem, make subarray. There is a canvas with n total cells, and each cell can be painted either white or a black. Currently, the state of the board can be represented by a binary string s, where s of I equivalent to 1 if and only if ith cell is in the canvas is painted using black, and s of I equal to 0 otherwise. So if I have to explain in a very easy term, you are having a canvas with n cells. Each cell can be painted using either a black color or a white color. Current state of the canvas is also given, saying that if any cell is equivalent to 1, it means that it is painted black, otherwise it is painted white. You want the black cells to form a contiguous subarray. Whatever the cell with the black color is there, we want to form a contiguous subarray. If cell X and cell Y are colored black, then all the cells Z between 2 must be also be black here. That means if there are two black, like if I want to paint entire cells, if I want to like cell X and cell Y to be colored black, then all the cells in between them, whether it's a white color or a black color cell, everything has to be black. Note that if there are no black cells, this condition is already satisfied. You can only change color of a cell from white to black. If it is a white color cell, we can change to black, but not the other way around. We cannot change black color cell to white color. That is not possible. Find the minimum number of changes needed here. What is the minimum number of changes need to make a contiguous or subarray cells of contiguous subarray of cells of black here? We need to check that. If there are no black cell in the canvas, the condition is already satisfied. Let's look at the sample input and output for more clarity. You are given the size of the canvas, how many cells are there, what is the current state of the canvas is also given. If you look at the first example, there is no black color. I don't have to do anything. It's already condition is satisfied. That's why the output is 0. Coming to here, there is some black cell here and there is some black cell here as well. I want to make this as a contiguous black cells. So I can change this white cell to black, and that will take only one cost here. That will only take like one change I need to make here. Coming to second one, there is already a contiguous here. Black cells are already contiguous. I don't have to do anything. That's why 0 again. Coming to here, if you look at the last test case here, there are total 10 cells. There is a one black cell here. There is one more black cell here. I want entire these black cells to be a contiguous subarray kind of thing. That means whatever the cells are there in between them, I have to make the white cells as a black cell here. That means I need to make these 3 white cells as a black cell, these 2 white cells as a black cell. So total how many changes I need to make? 3 here and 2 here. That is going to be 5. That is going to be 5. Or if I have to take more example, if I have to tell you like with the more example how the thing should look like. So if I take another example, let's say that is going to be 0, 0, 0. Let's say 1, 0, 0, 1, 0, 0, 1, maybe 0, 0, 0. So here our output should be, I want to make entire this thing as a contiguous blocks of black color cells, contiguous subarray. So how many changes I need to make? 2 white cells should be converted to white, 2 white cells should be converted to black here as well. So total for our output should be 4 here. So what do you think? How can we solve this problem? Can I say that this problem can be solved using, if I find the first occurrence of the black cell and if I find the last occurrence of the black cell in the given canvas. Here I know that the first occurrence of the black cell is at some location 4, or the, if you take like based on the indexes, it's going to be index 3. Okay, starting index is going to be 3. And if I talk about like ending index, where we are having black cell at the end, it is going to be at some index, this index, right? It is going to be at this index, ending index 8 here. Now this is the case. Now how many in between them as well, how many cells are already black? 1, 2, 3 cells are already black. So first I will find out what is the length of the here. What is length here? Can I say that can be simply find out using the, how do we find out? It is 8 only, right? 3 here, 3 here, 6, 3, 9, 10. Okay, this is some index 9 here. So if I have to find what is this length of this subarray, it is going to be, this length is going to be end minus start plus 1. That is going to be 9 minus 3 plus 1 will be equivalent to 7 here. Now out of them few cells are already black. I don't have to change them again. 1, 2 and 3. 3 cells are already black, so I don't have to change them. So actual changes that I need to need, already black cell would be equivalent to, if I have to find out how many already black cells are there, it is going to be 4 here. It is going to be 4. So our answer is going to be length minus already how many black cells are there. If I subtract them, that is going to be our answer here. 7. Okay, not 4. Number of black cells are going to be 3. Okay, so 7 minus 3 equivalent to 4. That means there are 4 white cells in between them, which we need to convert it to white cells are there, which we need to convert it to black here. Let's try to do the same thing. So number of test cases I have taken, I will take the string here. Okay, length is given first. So length I will take in 10, CNN. I will take it as like here, creating a string, read string here. String is, now I need to find first occurrence and the last occurrence. And I need to find the frequencies of one as well. So if I say, I will make two variables, first one equivalent to -1. I will also have something known as what is the location of last one as well. I will have that as well. Last one equivalent to -1. What else do we require? First one, last one, and I also need what is the frequencies of one? How many black cells are there totally? So count 1 I can take. Initially it's going to be 0. I will start from the index 0. I will go till all the indexes. If s of I equivalent to 1, I need to do something. I need to know whether is this our first time we are visiting a black cell or something. So here a simple way would be is if s of I equal to 1 and if our first one is still equivalent to -1, I can say that first one equal to current index I. Same condition I can write here as well. If s of I equal to 1, I will always increment whatever the number of count of ones, and I will say last one equal to index I here. At the end, what we need to do? I need to check, is the count equal to 0? If the count of ones equivalent to 0, if there are no ones in the canvas here, can I say our answer is going to be 0 here? Our answer is going to be 0 here. If that is not the case, our answer is going to be whatever the length, I can say answer is going to be length here, last one plus last one minus first one, last one minus first one plus 1. I need to subtract how many count of ones are there. I need to do so. Count of 1, I need to subtract them, and that is going to be our answer here. Last one minus first one plus 1 minus count 1 here. Same like what is how many black cells we are already having. We need to do so, and that much should be sufficient. Let's try to run our code. Let's see if it is we are getting the same output for the sample cases. Let's try to submit it as well. It is being accepted for the hidden test cases as well. So that's all for the second problem. Okay, coming back to the third problem, adjacent sums. You are given an array of size n, okay, n greater than or equal to 2, containing the non-negative integers, is called good if and only if following conditions are being met. What is that? A of 1, like a of 1 equal to a of 2, or a of 1 equivalent to 0, a of n equal to a of n minus 1, or a of n equal to 0, or I can say any a of I should be equivalent to the a of I minus 1 plus a of I minus 1 plus a of I plus 1, or a of I has to be 0. This should be satisfied for all the indexes from 2 to, like from 1 to or I can say from index 2 to n minus 1. That condition should be satisfied here. Let's formally, we need to all we need all non-zero a of phi equal to the sum of its adjacent elements here. Okay, you are given a array of size n containing non-negative integers. In one operation, you can add one or subtract one from the some element in the array. It is not allowed to make elements in the array negative at any point of time. We cannot make any elements negative or something. We need to find the minimum operation to make array A good. It can be proven that it is always possible. It's not like it's sometimes it's not possible. It's always possible to make the good array here. So I hope overall the questions are clear. So if I have to tell you in general what is the question here, question is that already you are given some array of size n. For all, you have to make this array good, and when we call this given array good, whatever your first index element is there, it has to be either 0 or a of 1 has to be equivalent to the a of 2. Last element can be 0, or it has to be, if it is present other than 0, it has to be equivalent to the previous element a of n minus 1. For the remaining whatever the other indexes here or the elements here, a of I has to be equivalent to a of I minus 1 plus a of I plus 1. That means whatever the current index that you take, it should be equivalent to its adjacent element sum. It should be equivalent to that. Let's see sample input and output for more clarity. What is given in the input? We are given a number of test cases. Each test case contains multiple lines of input. The first line of each test case contains size of the array, and we are given the array elements. Okay, that's it. If I take 0 and 5, okay, if I take the first input here, 0 and 5, can I say that, okay, 0, this is fine, but it should be either 0, I can make this as a 0, then also I need to make 5 changes. Like we know in one operation, if you guys remember, in one operation either we can add 1 to the current element or we can subtract, but any moment of time element should not go to negative here. So either I can make this 5 as a 0, or this is if I do so, then also I will take 5 to operations, or if I don't want to do so, here 5 will only be there and here I will change this 0 to 5. In that case as well, the operations are going to be 5. That's why the output is 5 here. Coming to second one, 3, 4. Again same thing, when I am having 3, 4, why, or if you guys remember, always the solution is possible. You make this as a 0, you also make this as a 0, but the number of operations to make both the elements as 0 is going to be 7. You subtract 3 times here, you subtract 4 times here, number of operations are going to be 7. Or I can do a better thing here. When I am having 3, 4, why to make both of them as 0, I can change this to 4 here. Okay, instead of making both of them as 0, I can take 3 and 4. I can convert this as a 4, and the number of operations are going to be 1. Only one operation is needed. That's why the minimum number of operations need to make the array good is going to be 1. 0, 0, 0, already conditions are satisfied. I don't have to do anything. Next one, 2, 2, 1 here. Either I can make this as a 0, or I can also make, see, you cannot make this as a 2. If you make this as a 2, what is going to happen? That means this value has to be 4 now. Left plus right sum, adjacent elements sum, 4. So the only operation that is possible here is that I make this as a 0 here. That is going to be one operation. If I take next one, important, let's see the next one, 6, 7, 2, 1, 2. One possible way is always there, that is you make everything as a 0. That is always there, and if you do so, the number of operations required are going to be sum of the array elements. But that is not the minimum. That is a valid one, but that's not the minimum. So here I can say this is okay, but other thing can be, I can make this 2 as 0, so the number of operations so far is going to be 2. Still I need something. I can also make this also as a 0. So the number of operations are going to be 4. Or I can do one thing. Instead of doing so, I can make this as a, like, I can increment it by 1. This is going to be 2 and the number of operations are going to be 3. But now I need to increment this as well, because 6 plus 2 is going to be 8. I can place a 8 here. But if you do so, that's not the correct thing. This will also, like, this is also one of the possible way, but this would be incorrect, because a of 1 should be equivalent to a of 2 here. That would be incorrect again. So again, what you need to do, maybe you will convert this as a 8, or this is not some valid one. Let's see what is the other possibilities. Let's see from the start what is one more possibility here. I can make, why don't we make this as a 2 equivalent to this one? So the number of operations so far is going to be 1. But if you make 2, this is not equivalent to adjacent sum. You make this as a 0. That means total number of operations are going to be 3. And either you increment this to 7 or you reduce this to 6. Anything is fine. So here you will reduce 1 and you will make that element as a 6 here. So the number of operations are going to be 4. 4 operations are needed. And this is your good array, I can say. 66022. Other possibilities are also there. You can do 77022. That is also okay. But that is also going to take 4. There is no chances where we can make this array as a good array in less than 4 operations. If you look at the last one, we can make this as a some 2020000. That means you are incrementing the values by some 1 billion here as well. 2 is there, right? So I can do the same thing for here as well. And same thing I can do for this as well. Some 2 billion. And total the number of operations required are going to be 3 billions here. I hope the sample input and output is clear. So how do we solve this problem? Can I say that if you want to make your array good, one of the options are you make entire thing as a 0. I will erase all these things. One of the possible way for is that, why don't we make everything as a 0? You make all the elements of the array as a 0. That is one of the possibilities, but this is not some efficient one. This is not the efficient one. Let's say initially you make few elements as a 0 here. Can I say that after some time you are making one of the element as a x? Okay, there are some initially zeros in the array. You make the some zeros in the array, or already zeros are there. After that there is some element x. If you want to make the array good, can I say that our next element should also be x here? Then only this condition will be possible, or we will be able to make this array good. Can I say that there can be some again zeros in between? Again we need an element. If there is an element y, there has to be one more element y here as well. Then only the array good condition would be true here. Same thing, few zeros again. There is some element z and there has to be some z again. That means there will be pair of elements in between. Zeros and then some pair of elements here, then some pair of elements here, then there is some pair of elements here as well. Okay, so at each and every index we are able to assume that there are some options are here. At each and every index we can do few things, or few options are available. One of the option is that if you are at any ith index, let's say if I am at some any ith index of the array, one of my always possibility is that, or the options here is that, make that thing as a 0. Okay, if I do so, what is the cost here? I can say to make any element as a 0, what is the cost that we are going to take? Can I say you reduce that element by 1 every time? That means you need the array of I operations would be needed here. This is like one of the possibilities. Okay. Or you want to make this element x here, or you want to make element equivalent to the previous element. Okay. Can I say that? Let's say you want to make the ith index as 0, a of I operations are required. You want to make the ith element as same as the previous one. If you want to make the current element equivalent to the previous one, either you have to decrement to make equivalent, either you have to decrement that x element, ith element, or either you have to increment, anything can be there. But to make current element equivalent to the previous element, how many operations do we usually require? Can I say whatever the difference between them? Whatever the difference between them, that is minimum number of costs that is going to require absolute. And I need to take care of one more thing here. I need to take care of one more thing. That means whatever the I minus second element or I minus 2 index element is there, that has to be 0 now. Only taking care of current, previous is not sufficient. I need to go one more step behind as well. I need to make sure that my previous element is 0. Then only from here to here, my array is going to be good. That means, and how many operations are required to make the I minus second element as 0? Can I say a of I minus 2, these many operations are required. A of I minus 2, these many operations are required. Now we have two options as I told you. Option number 1, we are having option number 2 as well. You either make the current element as 0, or second one, you make current element equivalent to the previous one, plus you make the large like I minus 2 element as a 0. That can also be done. That can also be done here. Now I need to check what is the, like as I have to find the minimum cost, I need to take minimum of both of them. I need to take the minimum of both of them here. So are you guys able to imagine like how can we solve this problem? At each and every index, we are having two options. Already you might have solved, if you these kind of problems where you are having at each and every indexes, we might have few options. Maybe problems like subset sum, robbing the like house robbing, that problems, or like any like DP problems, subsequence DP problems, where you will have the in like options at each and every index, and you try to take whatever the like you will go with both the options, whichever is giving you the minimum cost, you will go with that. So like if I have to think now in terms of a DP direction, like how the DP state and everything is going to look like, at any in any DP of I, we will try to store minimum cost to convert array of index 0 to I as good. We are not worried about the entire array here. What is the minimum cost to convert a array from index 0 to I as good? What is the minimum cost? We'll be storing in DP of I here. Now, for any DP of I, we have few options. For any DP of I am having few options. That options are, I need to take minimum of both the options. That is going to be make the current element as 0. That means the cost is going to be array of I here plus what is the cost we have taken so far, that is I minus 1. What is the cost we have taken to make the array good till I minus 1? Or second option here is going to be cost to make the equivalent, make the current element previous to the like equivalent to the previous element, absolute of array of phi minus array of phi minus 1, plus I need to make the second element as like I minus second element as 0, and that is going to be a of I here, I minus 2, plus array of I minus 2, plus what is the minimum cost to make I minus 3 elements as good here, that is going to be dp of I minus 3. And again, like there will be few base conditions and everything. One of the base condition here can be, can I say the base condition here can be if there is only single element in the array. if there is only single element in the array, I don't have to do anything, I guess. Only one element is there. But here for sure you are going to have the two elements. That is when you are always going to have the two elements, I guess. Yeah, let's try to convert this entire logic using DP into code as well. Let's start with coding of the adjacent sum. What all we are given to us? We are given the number of test cases, size of the array I would take, creating an array of size n. I would create a DP as well. I will create a DP array of size n. We can say that DP of initial value is going to be array of 0. And for remaining elements, for the remaining elements here, for remaining elements from 1 to n here, two options are there. Either I can say DP of I will be equivalent to option number 1. What is the first option do we have? You make the current element as 0. So for that, the cost is going to be, array of I. And our second option is, here I can write, make current element as 0, or second option that we have, I need to make current element equivalent to the previous one. That is going to be, so here I can say cost here. For the second option, what is the cost that is being taken? So absolute of array of I minus array of I minus 1, array of I minus 1. I need to check if I minus 2 greater than or equal to 0, then I can say cost plus equal to, I need to make the I minus 2 also as a 0. The cost to make the array of I minus 2 as a 0 is going to be array of I minus 2 here. And if I minus 3 greater than or equal to 0, I can say the cost is going to be DP of, okay, here also we missed, we need to take DP of I minus 1 here. And here I need to take DP of I minus 3 here. What is the cost to make I till I minus 3, 0 to index I minus 3? What is the cost to make the good array here? And here I can say DP of I equal to minimum of DP of I comma whatever the cost we got from the second option. We'll always take the minimum. At the end, I need to print DP of n minus 1 here. Let's try to run our code. Okay, 51014. Anything else that is given in the question? Output format, minimum number of operations to make A good. Okay, I need to take this as a that's the thing, I guess. I need to take this as a long because we have 33639. Okay, I can also make this as a long. Somewhere I have taken a long, somewhere I have taken an integer. Long I have taken here also. I need to write it as a long. Yeah. Yeah, that's it.
Thank you for watching this video. If you like the content, like, share, subscribe to Smart Intuitive channel for more such content.